Hi everybody, we're at the point in the chapter where we really have just one topic left. So what we wanted to do at this point is do a quick recap of everything we know so far from this chapter. So if you'll think back, when we started off, we started solving systems of linear equations. So I'm going to make a note here. This is for solving systems of linear equations. Because we've been working with inequalities recently, so I want to point out that this was different. We were just starting off with linear equations. And we knew when we were solving systems of linear equations, we could do that in one of three ways. The first way we could do it is by graphing. The second way, and I'm going to run out of room here, was substitution. And the third way, I guess I'm going to have to go down here, sorry about that, is elimination. So this is where we started. Now, we also learned that when we solved, one of three things could happen. The first is that we could get one solution, and this is where we really started in the chapter. So one solution meant that if I graphed my system, I would get two lines that intersect at one point, and we called that point the solution. And we always wrote the solution as an ordered pair. So we had parentheses and then our x and y coordinate. Now, when we were solving by elimination or substitution, we would get something, right? We would cancel out one of the variables or we would substitute. We would get something like x equals 3, and then we would substitute to find the y value. And then again, we would write that solution as an ordered pair. So that's when we had one solution. Now, when we got no solution, graphically what that meant was we had two parallel lines, so lines that never intersected. And since they didn't intersect, we'd say no solution. Now, if we were solving by substitution or elimination, we would find out that all the variables cancel. All variables cancel, and we are left with a false statement. So something like 0 is equal to 3. That let us know that there was no solution. And then the last possibility we could have was infinitely many solutions. And what happened there was if we went to graph, really we'd find we had the same line. If we went to graph our second one, we were just graphing it right on top of the first. Now, if we think of it, if we used elimination or substitution, it was similar to no solution, so we still had all variables canceling. But in this case, we were left with a true statement. So for example, 0 equals 0. So that's where we started with solving systems of linear equations. The next thing we moved to was graphing systems of inequalities. So now, instead of equal signs, we had our inequality symbols. So let's take a look at what this looked like. We know that we first had to graph our equation. So in this case, my m was a -2, so I'm going to make that -2 over 1, and my b is a -1. So b is a -1, my slope tells me to go down 2 and over 1. Since this is less than or equal to, I'm going to use a solid line. see if I can use my ID here. So that's going to be a nice solid line all the way across my graph. And since it's less than, I'm going to shade below my line. So if I pick any point on my line, I want to shade down from there. So that means this whole part of the graph would be shaded. Now for my second line, I have M is a positive 2, so 2 over 1. My B is a positive 3, so I'm going to go up 3. I'm going to go up 2 over 1. And now this time, since it's just greater than, I'm going to use a dotted line. So I am going to draw in my line with a dotted line. All the way across. And now because it's greater than, I'm going to shade above. So if I pick any point on the line, I want to shade above it, which means I'm going to shade here. And now remember, the whole point was that the solutions lie where those shaded areas overlap. So I can see here I've got my blue and my green overlapping. So I shade this in to make it really clear that this is the area where all my solutions are. And remember, the big idea here is that any point, any point where the shaded areas overlap make both inequalities true. Oops, I'm sorry, you can't see that. Let me show that so you can get that. So if I picked any point in this shaded area, if I plugged it into both inequalities, I would get true statements. All right, and then to finish, oops, sorry, that made it worse. To finish the chapter, we didn't have to graph anymore, but we had to write the inequalities for the system. So I'm going to use colors here. I'm going to start with this line. So I can see on this line that my y-intercept, my b, is -2. If I find another nice point, let's see, it looks like that happens here. So my slope is 1, 2, 3, 4, 5, -5 over, let's see, over 3. Now, I also know since it's a solid line, I'm going to have a greater than or equal to or a less than or equal to. And it looks like here it's shaded below. So I'm going to have a less than or equal to. So my inequality would be y is less than or equal to -5/3 x minus 2. Now for my second line here, my dotted line, it looks like my y-intercept is a +2. So there's 1 point. And it looks like another nice point is here. So my slope is negative again, -1 over 3. In this case, I'm shading above, so I know I have y greater than -1/3 x plus 2. And since it's dotted, it's going to stay strictly greater than, not greater than or equal to. So that's just a quick review of everything we've done so far, and our next lesson will be moving on to modeling with systems of equations. Again, if you're having trouble with any of this, please make sure you're either coming to me for help or you're going to seek help in the MRC. All right, that's it for now. Thanks, and I'll see you in class.